Hello, everyone, and thank you for attending today's webinar, Accurately Modeling the Economics of Customer-Sited Energy Storage Projects. I'm Kelsey Misbrenner, editor with Solar Power World. Before we begin, we wanted to let you know about our application widgets at the bottom of your screen. You can move and resize them however you'd like. Slides are available to view at any time via the Resource widget. Submit any questions related to today's webinar via the Q&A widget. Our presenters will send answers afterward to the email you used to sign up for today's webinar. We encourage you to tweet with us. Simply sign in through the Twitter box. Today's hashtag is automatically added to your tweets. And finally, if you're watching this on demand, you can still use all the features I went over. Let's get started with today's webinar, Accurately Modeling the Economics of Customer-Sited Energy Storage Projects. Today's speaker is Adam Gurza. Adam is the COO at Energy Toolbase, a software platform for modeling and proposing the economics of solar and storage projects. He's worked in the solar and clean tech industry for the last 9 years in various project development and policy-related roles. And now I'll turn it over to Adam.
Awesome. Thank you, Kelsey, for the intro. And thank you to Solar Power World for hosting this and rounding up a big audience. I'm looking at the attendee list. I keep pressing refresh, and I think we've already got a couple hundred folks on the line, which is really awesome. And I think speaks to, the interest and the timeliness of this topic right now. So I want to also just quickly say thank you to everybody on the line. I mean, I know there's a lot of webinars happening these days, a lot of events in our industry. So kind of appreciate you taking time out of your day to check this out. So on behalf of Energy Toolbase, we are and we have been thinking a lot about behind-the-meter energy storage over the last several months. And it's, kind of a privilege because we're talking with a lot of the leading manufacturers in the space right now and leading vendors and developers. And frankly, we're learning a lot right now. So a lot of this presentation today is about us kind of sharing a lot of those insights and also in the process giving you a good overview of our recently launched energy storage software update. So without any further ado, let me go right to the agenda. Actually, that's already up on the screen there. I'm going to do a very brief overview, just kind of telling you a bit about the recently launched storage update. I'm going to kind of do general remarks on storage performance modeling and different techniques and methodologies that are out there. And in the process, kind of show you exactly how we've approached that problem. Going to run through a really quick overview of the primary inputs that really dictate the economics of a customer-sited storage project. And then I'm kind of targeting to reserve most of the time today to really run through real-world case studies. And you can see the 3 examples there on the screen that I'm going to be going through. I've got a few projects queued up that look attractive and make sense, and also the other side of the coin. We have some that just frankly don't pencil, and hopefully there'll be kind of takeaways on the different variables that are kind of making that so. And then lastly, just kind of summarizing it with a lot of these learnings that we've gotten over the last several months in talking to developers and seeing folks get projects to the finish line. So that is the next half hour or so. I've got one slide on Energy Toolbase just to kind of kick it off. I'm assuming most of the people on the line today know who we are. For those of you that don't, Energy Toolbase is a software as a service application for modeling and proposing the economics of solar and storage projects. And the one thing that we're really kind of known for and specialize in is utility rates and avoided cost analysis, which is kind of just a fancy way of saying figuring out how much a project saves in dollar terms. And that's really what we're going to be looking at today. And just a little context, we now have over 1,000 organizations across the country using our service, solar companies, installers, developers, energy consultants, and even a few utilities now, which is exciting. Okay, so that's a general overview on Energy Toolbase. From this point forward, everything's really going to be about our newly launched energy storage software update. So this was a really big deal for us. This was over a year of planning, and it was about a 6-month engineering cycle to build and release this. We went live almost 2 months ago to the day. We went live back in early September over Labor Day weekend. And basically, this was a really fundamental refactor of our storage modeling capabilities. And as you can see on the screen here, in one sentence, what the product vision was to give users the ability to objectively and transparently figure out the savings, figure out the economics for any type of behind-the-meter customer-sited energy storage project. So, that's obviously a pretty big statement because that encompasses many, many different things. That's RESI, that's CNI, as we're going to look at in a minute. That's peak demand shaving and time of use arbitrage. And I'm really going to kind of show you the exact approach we've taken to try to answer that question and try to deliver on that vision. So let me next go to just a quick summary as I kind of set things up before we dive into the case studies on what we consider to be the primary inputs, so the primary variables that really are going to kind of dictate the economics of your behind-the-meter project. So I'll run through each of these pretty quickly. The hardware side is pretty obvious. We're talking about the battery and inverter product specifications. So obviously there's a lot of vendors out in the market, and even within those different manufacturers and vendors, there's different make and model systems. And really on the hardware side, we're talking about the system characteristics, things like the max kW power of a storage system, or the total kilowatt hour energy capacity, or the round trip efficiency, as some examples that we'll look at. On the software side, this is really going to be kind of the next two slides, but we use this term control strategy. What we're referring to there is the operating system on how the hardware, on how the battery is operated. When does it discharge? When does it charge? What value streams is it going after? And really most of today's presentation is going to kind of be unpacking the ESS control strategy. Another big one, and this is an obvious one, it's the customer load profile. And I've got in parentheses here, what we're kind of more or less talking about is the green button data file. It is a prerequisite to have granular interval meter data for your customer in order to, realistically or ethically model the savings or the economics of a storage project for a particular customer. So it is a requirement to have that, and it will absolutely dictate the savings opportunity. The utility rate tariff. At the end of today's presentation, I will drive this point home that this is certainly one of the biggest determinants of whether a project is going to make sense or offer up a savings opportunity, or frankly not, because there's a lot of rate tariffs out there that just don't. What I mean by DER combinations, so distributed energy resource combinations, what we're referring to here is, are we modeling a standalone storage project? Or are we modeling a storage plus PV project? Or other combinations, energy efficiency or demand response that you're pairing in. And then lastly, an obvious one is incentives. So from there, I want to kind of do a really quick overview on this term control strategy that we use. And this term can kind of be used interchangeably with the battery management system. And again, this is the software layer or the instructions that dictate when the battery charges or discharges. And obviously it's determined by the value stream opportunity that the BMS, the control strategy, is going after. It's also determined by any other rules or constraints. For example, maybe you have a constraint on the battery management system that says energy storage must charge from solar. Or maybe you don't have a constraint there. Maybe you have a rule that says when you run your simulation, energy storage cannot export to grid. Or maybe you do not have a restriction there. So that's really kind of the set of parameters, and we're going to look at those and exactly how you define those in Energy Toolbase in just a second here. Okay, I've got one last setup slide. I've been giving variations of this presentation a lot recently, and I kind of want to include this slide and just talk very briefly because I think I want to draw a line between the two types of kind of software performance modeling tools in storage. So when we think about forward-looking performance modeling, we're kind of talking post-commenced operation date. Basically, for an operational storage system in the field. And there is a software control layer that is making predictive decisions that is dictating how that battery is charging and discharging. And again, based on some of those things we just talked about. If it's trying to optimize for peak shaving, sometimes this gets to be very, very sophisticated. You know, they're doing machine learning things, and there's companies that really specialize in this. That's not what Energy Toolbase does at all. We're exclusively in this backwards-looking category. Again, just as a disclaimer, Energy Toolbase is a sales and analysis tool. We do everything up until the point of sale, right? So this is before commenced operation date, and the way we do our modeling, as we're going to look at, is really utilizing historical usage data, and then we're going to run a simulation on top of that historical data based on how we've defined the hardware and the software and the control settings. So I just kind of want to make that distinction because we're about to dive in deep to that, so hopefully that becomes clear. Okay, without any further ado, I am going to jump into the demo section. Also, quick heads up, I think with this client on 24, Kelsey and Lisa warned me in advance, you guys may get a message on your screen that says enable flash. So you may need to enable flash to see this. So just go ahead and click yes. Okay, cool. So I am in our application in a demo account on a dashboard page. And I do realize that some of you are probably seeing this for the very first time. You know, this is a demo webinar today. This is not a training. So I'm going to be kind of moving fast and jumping around, and I'll just kind of narrate some of the stuff that I've already set up. I've actually chosen to switch the order today. I usually always do peak shaving first, but we're actually going to do self-consumption to start with. And this is a new one that I've got configured here. And in order to talk about self-consumption, you really have to run a PV-only project to start with. So let me just kind of talk through what I've set up here. Okay, so self-consumption. This is going to be all about using a battery to prevent exports to grid. And the example I chose here for this demo is Hawaii. It's the classic example for self-consumption because there is a very strong price signal in Hawaii to not export solar to grid. In step 2 of my project here, this project is on the Hawaii Electric Company rate schedule R. And this is a really key thing to point out, which is this is a customer self-supply option deal. Under the customer self-supply option tariff, if you export solar to grid, that energy is valued at 0. So that's kind of how I've got this configured here in step 2. Again, this is a solar-only deal, so let's just kind of get some context for what I've set up here. You can see this is an 8.4 kW DC-rated solar system. I'm going to snap open my little facility summary dashboard on bottom just to give context. So the usage profile that we're going to look at in a second, this was actually my house. We're actually using real data, and it was data from my house. I used 13,241 kilowatt hours annually last year. Based on that 8.4 kW DC rated system, our solar is producing about 12,000 kilowatt hours annually. So this is a key number I want you to look at, which is the annual offset. This is a pretty fully sized solar system. It's a 90% offset system. Okay, let's look at a visualization really quickly just to kind of get our head around this. So I just jumped into our analytics module, and this is our demand profile visualization screen. This is a really awesome tool when you're modeling storage projects, just complete visibility into kind of what's happening. So let me kind of zoom in on a week. I'm going to remove a few of these layers, and this is just my load data. This is my house. What I'm doing here now is I'm hovering my mouse over one of these peaks, and I kind of just want you to get your bearings and look on bottom. My peak there on August 2nd was 9:15 in the evening. If you notice, there's kind of a common thread here. A lot of my peaks are late in the evening, which is pretty characteristic of a residential usage profile. Okay, so let's overlay our solar. And you can see a lot of the solar obviously is kind of at the peak of its bell curve around noon. And let's overlay our net. So check out the net. I have a little bit of lag on the screen, by the way. There it goes. You can now see the net. And the net is effectively, I really want to kind of key in on exports. Exports are the light blue energy below the line there. And you can see it's basically an interval where we're producing more solar than we're using. If I was to zoom out all the way to the full billing cycle range, you can really visually see it there. By the way, this is July 24th through August 24th. But the big takeaway here is there's a lot of energy getting exported to grid for our 90% offset system. We have a really nice summary view. If you jump back to the dashboard, I'm kind of hovering my mouse. I'm waiting for the screen to catch up. There you go, over here on the right. And under the export value, you can see 64% of all of our solar production is getting exported to grid for this project I set up. You know, that's crazy. We're talking about 2 out of every 3 kilowatt hours is being sent back to grid. And then the way we've configured this project in step 2, this customer would be getting killed, right? I mean, two out of every 3 kilowatt hours is worth 0. And you can actually see that effect here. The average blended cost of energy for this customer is in the 27-cent range. The average blended value of solar is under a dime. And it's obviously a result of the fact that so much of our production is getting valued at 0. Okay, so this is obviously an unrealistic project. Certainly in Hawaii, you would never sell your system. You would never sell your customer a system that's exporting that much energy because the economics is just giving energy away for free. So let's go now. Everything else equal, I've kind of copied, duplicated that deal, and all as we're doing here is we're going to add in a storage system. And that's managed through step 5 here in our edit proposal screen. Let me just kind of give you a really quick setup for the different variables that a user dictates. There's basically 2 sets of variables. One is the hardware side. We're kind of calling this the system characteristics. For my demo deal here, I have a 10 kW, 20 kWh storage system. So that's a pretty good sized residential storage system. I'm running this at a 90% round trip efficiency and 100% depth of discharge. On the control setting side, this is the instructions for how to run the simulation. So let's just kind of look at the back end of this. I've got 2 restrictions here. Number 1, I'm saying must charge from solar. Okay, you can only charge the battery from solar, so we can kind of turn that on or off. I've got that turned on. And then the other instructions are basically saying prevent exports to grid. So that's the only thing we're telling this 10 kW, 20 kWh battery to do. So let's look at the visualization, and it should be really clear what's happening here. Okay, there's obviously a lot of data on the screen right when you open it up. Let's kind of just zoom in to a week, and let's do one thing at a time here. So I've got usage data on the screen only. Let's go and overlay our solar production. Okay, those would all obviously be exports. Now let's layer in our charge-discharge profile. So that's the battery performance data. And actually, I'm just going to click all of them on concurrently, and we'll talk through this. Okay, so it looks like there's a lot of data on the screen, but you really kind of need to interpret this to find out what's happening. So let's really key in on this day right here. August 2nd. If you see where I'm hovering my mouse, a really key data point is the red dotted line. That's state of charge. So we're coming into the day empty. And what's happening is as we, actually let me zoom into just a couple of days there, which is really cool. It's a really dynamic module here, this visualization screen, which is nice. Okay, here we are. We're coming into the morning on this one day, August 2nd. We're producing more solar than we're using, and the battery is doing what we would expect it to do. It's charging. It's charging, it's charging, all the way up until 2:15 in the afternoon. 2:15 in the afternoon, where I've got my mouse hovered right now, we've hit 100% state of charge. That's another way of saying our battery is full. We got no more room left to store energy. So as we go later into the afternoon there, you can actually see some exports to grid. That's that light blue line. If we go out to a full range, you can actually kind of sort of see that same effect for a lot of different days based on this simulation. So the battery's doing what we instructed it to do. It's preventing exports to grid, but the way the solar system is sized relative to the customer load, and based on this battery system that we spec'd, 10 kW, 20 kWh, we still are getting a little bit of exports. We've got a really nice summary view. If I was to click out of here, let's kind of just add it up. What happened? So everything was the same except for the battery. And over here on the right, this is kind of what we looked at earlier. Whereas before we were exporting 66% of our energy to grid, we're able to knock that all the way down to 10%. So that's That's very, very significant, obviously. And for this particular project, where you have a really strong price signal to not export to grid, we're going to do really well. And this is also another awesome summary view here in step 5. The title of this presentation today is Quantifying the Savings of Storage, Quantifying the Economics of Storage. It's the most common kind of question and inquiry that we get is, well, what did my project do in dollar terms? And we've got a really nice kind of transparent summary of that number. In dollar terms here, the blended savings on a dollar per kilowatt hour basis is $77 per kilowatt hour. That's basically taking, and it's over the kilowatt hour capacity. So a really quick way to kind of calculate what that is, it's basically $77 times 20 kilowatt hours. So we were actually able to save $1,540 for this storage system, this 10 kW, 20 kWh, for this particular customer, just purely from storage. And obviously, this is an extreme example. This is Hawaii, and this happened to be for a customer exporting a lot of energy. Okay, now this is going to be a really awesome segue to show off our optimization engine. So a lot of you are probably already thinking, well, okay, this is cool, this is good, we got it down to 10% export, but wait a second. In Hawaii, I'm being told I can't export at all. My question is, what system size do I need to size to make sure I prevent all exports to grid? So let me show you how we run that goal seek. We have a really, really clever and really usable kind of intuitive tool, and that's our optimization engine. Okay, so we're going to run this optimization, and it's based on all of the instructions we've already defined. So let's scroll down to these charts and kind of interpret a little bit of this. And I'm actually looking at my clock. I got to move on quick because I want to show ToU arbitrage and I also want to show peak shaving. But let's look down here at this bottom chart. And in the x-axis, we're showing the kW by kWh system rating. These are all 1-hour duration batteries. I'm actually going to throttle this up. I'm going to scroll back up here, and I'm going to kind of throttle this to a 2-hour duration battery, and it'll become very clear what I mean by that in just a second. Okay, so I'm rerunning the simulation now based on a 2-hour duration battery. So what does that mean? What that means is, as I hover my mouse right here on the chart, this is now simulating a 10 kW, 20 kWh. That's kind of what we're referring to as a 2-hour battery. So the answer to our question, even at the far end of this range, at a 15 kW, 30 kWh battery, we're actually still exporting 3% of energy to grid. So I'd actually have to go back, size a longer duration battery, or even size a greater kW duration battery. Or alternatively, obviously, the other trade-off would be to size down our solar system. But hopefully this just gives you a little preview of our optimization engine. It's really incredibly powerful. We're actually going to look at some other examples in a second here when you're running this for different types of control strategies. So I'm going to wrap that one there. And I want to apologize in advance if I'm talking fast. I really want to get through a couple of different examples, but I, at the same time, don't want to throw too much at you in the course of the 40 minutes here. Okay, let's talk next about ToU arbitrage. For this particular deal here, I've got one that makes a lot of sense, and I've got another one that makes no sense for a ToU arbitrage control strategy. And the only thing I changed is the rate tariff. So for this one here, we're in the PG&E territory. I modeled 2 rate schedules, the EVA, which is an electric vehicle rate, and the ETOUA schedule. So let's start with the good news. Let's kind of keep this upbeat for now and start with a good-looking one. So let's go to step 5 really quickly and just kind of show you what I had configured on my sizing. For this deal here, my screen is catching up. We're going to do a very standard size, 5 kW, 10 kWh. And by the way, this is another residential project. But for those of you on the line that are thinking about, modeling and extracting value on time of use arbitrage in commercial applications, everything I'm saying absolutely applies. And we're going to look at peak shaving in a minute and kind of doing some stacking in a minute. So we're going to look really briefly at another resi one, but this certainly could be commercial as well. Okay, the instructions this time are, I should have set this up. We're actually going to do standalone storage here. The last project we looked at was solar plus storage. For this deal here, it's going to be apples and apples because we're going to look at two different deals, but this is actually going to be standalone storage. Therefore, we have no charging restrictions because obviously it can't charge from PV. And then the only instructions that I've given the engine this time is let's go out and do ToU arbitrage. So let's see what our simulation generates, and this should be pretty easy to make sense of here. Okay, I'm going to do the same thing as last time. I'm going to kind of remove a lot of these layers, and let's just zoom in to about a week. Okay, so right now we're just looking at usage data, and this data was built based on the Department of Energy, OpenEI, residential load profile customer up in the Bay Area, up in PG&E. And you can see he's got kind of a late 9:30 peak, and it's a very consistent looking load profile. Okay, so let's go and overlay our time use arbitrage simulation that shows the charge and the discharge. And I think I'm just going to go ahead and lay all the layers on the chart at the same time. So check out what's happening here. Basically, I should have set this up. I want to take a step back. On the bottom of the screen, this is actually really, really important. This is, again, the PG&E EVA schedule. And it's a really cool visualization because we can show you exactly the cost of that schedule. So I've got the energy charge costed where I've got my mouse hovered, and you can see the on-peak category, which is the top tier of energy, runs from 2 p.m. to 9 p.m. And the key number here is the on-peak rate. I realize this might be small for you to see, but the on-peak rate on the PG&E EVA is 45 cents a kilowatt hour. Okay, what about the bottom here? What is the off-peak rate? The off-peak rate, by the way, runs from, it looks like 11 p.m. to about 6 or 7 a.m. The off-peak rate is 12 cents a kilowatt hour. So 12 cents off-peak, 45 cents on-peak. That's a really, really wide differential. It's about as wide as you'll see. You know, we're in the low 30 cents, call it 32-cent range. Okay, now that we've got that defined, let's overlay our simulation. And again, this is a very simplistic one, but I just kind of want to prove a point. This is standalone storage. And check out what we're doing. Pretty straightforward. We're coming into the day with a full battery. This is July 20th. This is just one day. We get into that on-peak period, and they are, the way we've got this configured here, we're fully discharging the entire battery all the way down to 0. And then the minute we get into that off-peak category, we're fully recharging the battery. And that's, in effect, ToU arbitrage. We're buying low, we're selling high. And if I go out wide to the full date range of this billing cycle, you can see we're basically running that same full discharge, full recharge every day. One other thing to point out, this is a 7-day opportunity. This is a bit unique to electric vehicle rates. And what I mean by that, even over here on weekends, that 32-cent delta exists. So that's really, really important when you kind of want to step out of this and make sense of, well, after we run that simulation, what sort of savings did we achieve? And the answer is right there. We can kind of get to the answer the same way we did last time. Well, we're getting $80 per kilowatt hour, and we've got 10 kilowatt hours. So for that pretty normally sized 5 kW, 10 kWh storage system, we're able to extract $800 roughly of avoided cost, of savings just from the battery, just from the storage system, which is obviously very, very much a function of that rate tariff, the PG&E EVA. Okay, so that's the good news. Let's look at the bad news, and let's model the ETOUA. You can actually already jump ahead and look at the end result there. Like we were at 802, we're going all the way down to 31. We're almost not making anything here. So let's actually look at this. We're just, the only thing we've changed, everything else is identical. The load profile is the same, the battery system characteristics and the control strategy is the same. The only thing that changed is we swapped out the rate schedule. Now we're going to model the PG&E ETOUA. Let's unpack what that rate looks like. Okay, why don't we just zoom into a week or so. And on the bottom of the screen, you can see that the on-peak period, it's a little bit shorter. You notice that? It's from 3 p.m. as it's currently defined. By the way, this is the current effective ETOUA rate, 3 p.m. to 8 p.m. The on-peak volumetric rate is 39 cents a kilowatt hour. The off-peak volumetric kilowatt hour rate, 32 cents a kilowatt hour. Okay, so we're really getting squeezed here. Now we only have 7 cents of differential to go after. So our engine runs its simulation just like it did before. Why don't we go out wide and just look at what it did for the whole billing cycle? And you can see for the Monday through Friday weekdays, we're fully cycling the battery. We're still going to go out and capture that 7-cent opportunity. Notice Saturday, Sunday, there's no opportunity because that's all off-peak energy. One other really important thing I want to point out, which makes this a really, frankly, not doable schedule for storage. I want to toggle to a winter month. So everything we've been looking at so far is summer. Let's go to February, March. Check out what's happening in February, March. Let's zoom in and look at the delta of the tariff. The winter on-peak energy rate, 27.5 cents a kilowatt hour. Winter off-peak, that's not a typo. I'm waiting for my screen to catch up. There you go, 26 cents a kilowatt hour. So now we're talking about 1.50 cents of differential. That is very, very skinny, right? So if I go out wide and look at what the storage simulation did for this winter month, the answer is it did nothing. And this isn't a bug. It should have done nothing. And the reason why, and this is a really important insight when you think about time of use arbitrage just in general terms, if we go back to our step 5 settings, I really kind of want to plant this seed, which is round trip efficiency and how round trip efficiency relates to time of use arbitrage. So by the way, in Energy Toolbase, you can model integrated, this is an integrated inverter storage system. You can actually also configure and set up external inverter systems where you have efficiency loss both at the battery and separately at the inverter. This one here is an integrated system, and we're running this at a 90% round trip efficiency. What does that mean? Effectively, that means for every 10 kilowatt hours that gets cycled through the battery, you lose one of them to efficiency loss. So that's why we didn't do anything in the winter. Think about that. The differential is so skinny at 1.50 cents, we would literally be cycling at a loss, right? You could discharge on peak, you could fill up the tank in the middle of the night and capture that 1.50 cents. Well, you'd actually be doing that at a loss because your round trip efficiency loss doesn't even make up for that. This is a really good illustration why this is frankly a terrible schedule for storage, for time of use arbitrage anyways. One other thing I didn't mention, the winter, and this is really all about the winter, right? Because the winter just doesn't offer us an opportunity. Well, the way the winter is defined in this schedule, it's an 8-month winter. So we're getting squeezed again there. It's an 8-month winter, it's a 4-month summer. So those are the sorts of things on arbitrage that really illustrate that it's all about what the rate schedule offers. Not only about the differential, because that's important, but also how the seasons are defined, if weekends are all considered off-peak. And again, that's really what our engine, and actually to sum this all up, just to kind of do it the same way we did last time in step 5, we only ran 88 equivalent full battery cycles for the year based on our simulation, and the savings it's almost zero. There's just no savings opportunities. We could save $30 for the entire year running a perfect arbitrage simulation there. Okay, so that's ToU Arbitrage. Again, I'm kind of having to move fast because there's a lot of material to cover, and just teasing this for now. Let's step into peak shaving, which is kind of a whole conversation unto itself. So I've got a commercial project set up on peak shaving. Let's go into a storage-only project to start with. And this is, just to give us a little bit of context, we're going to model an SDG&E, San Diego Gas and Electric, ALTOU schedule. This is a, for those of you that don't recognize this schedule, this is a very lucrative, this is a great demand charge management schedule, just because it has very high demand charges. And again, this is storage only, so let's see what we kind of configured here in step 5. We've got a 40 kW, 80 kWh battery, and on the hardware side and on the control setting side, we are basically just doing peak shaving. So let's look at how that simulation runs and kind of interpret those results. Awesome. I'm seeing a lot of questions coming in. Please keep shooting those over. We're going to tackle those at the end, so keep chatting those over, please. I know I'm covering a lot of material, and it's maybe it's been more effective to kind of stop and pause, but we're going to do Q&A at the end. Okay, let's get some context for the load profile. Let's kind of zoom in here to a week. You can see this kind of looks like an office building type load profile. The way I make that statement is based on, I'm hovering my mouse over here on March 4th. You can see this customer starts to kind of ramp up at 6 in the morning, and they shoulder out until about 5 in the evening, right? So pretty typical looking office building, kind of 9 to 5, in this case 7 to 6. Okay, so let's overlay our storage simulation, which is based on a peak demand shaving algorithm that we instructed the engine to do. Again, 40 kW, 80 kWh. And you can see kind of the dark blue, the before demand or the before load, and then the light blue, the after. And you can kind of really start to see where we're shaving down to. And it's a pretty similar shave, just kind of, you know, shaving off the top of those spikes throughout the day. Remember, this is like a 10-hour shoulder. So this guy has kind of a long duration ramp up. So the 40 kW, 80 kWh size battery is just kind of able to take off some of the tops there. And again, we're looking at one billing cycle, obviously, to really unpack this and kind of think through this. A lot of times you're going to want to scroll from winter months to summer months and really just kind of get an idea of, you know, as the customer's load profile changes, how does the simulation go out and perform? And again, it's really nice in Energy Toolbase. We're really fully transparent to show you both at a detailed level and then at a summary level what happened. So let's unpack what happened. On a summary level, this is actually very, very lucrative. We're actually getting about $100 per kilowatt hour of savings. So 100 times 80. We saved about $8,000 doing this standalone storage project for this particular customer. For that 40 kW, 80 kWh. Again, standalone storage. Let's go now and look at pairing it with solar. And again, I've kept everything else the same. So when we go and look at this deal, the load profile is the same. The rate schedule is the same. The step 5 energy storage parameters are the same, 40 kW, 80 kWh. The only thing that we're doing differently in this particular deal here is we're adding in a solar system, a 75 kW DC rated solar system. So let's go and look at the visualization and kind of look at how the simulation changed. So let's kind of start with one thing at a time here. Let's just look at usage data. I like zooming in on a week. I think it just gives us a little bit more kind of focus on what's happening over the course of a week. Okay, so let's do same load profile. We're now in a summer month, which is why it might look a little different. This is July, August. Let's overlay our solar system. This data here, I believe we used our helioscope integration, which is one of our friends and partners. So the user chose to import in their 8760 production data from helioscope. Energy Toolbase is operable with every solar production calculator out there. So we got our solar overlaying against our load. Now let's look at this new simulation and notice it's really entirely different when we're pairing it with solar. And in this case, it's awesome because it's really, really complementary. I'm actually going to try this. Let's zoom into one day and just really kind of unpack and think through that day. So think about what's happening here. Early in the morning, the customer starts to ramp up on their load. Starting at 7 a.m., 7:30 a.m., they're already kind of spiking on their load. The solar really hasn't come online yet. You know, solar's just waking up at that point of the morning. So when we overlay our battery simulation for this day, check out what's happening. We're kind of really complementing the solar by shaving down that early peak and just kind of getting it until about that 8, 9 a.m. hour when the solar starts to come online, and that actually we can overlay net. So check out that net. You can really see a pretty significant reduction. Let me actually go out a little bit wider. Sorry, I'm jumping around a little bit here. What I want you to kind of key in on here is what the original load was, and then look at the light blue line. There's a big gap there, so this is awesome. The solar and storage is really able to knock out and shave down a lot more demand than the storage could do on its own, which again is a function of this load profile. And this load profile lends itself really nicely just because it's got that kind of 12-hour shoulder, 7 a.m. to 7 p.m. The solar really knocks out all of that usage midday. The storage complements it nicely by kind of discharging early in the morning, and then it recharges, and then discharging again late in the afternoon on the kind of back end of that shoulder. And that's a pretty similar looking simulation. You know, there's a lot that's been written about this topic and the, you know, how solar and storage are complementary with one another. A really great report just came out last week from LBNL and DOE, where they really kind of talked about the synergies and the increased saving opportunity from storage when you're pairing it with solar. And again, here in step 5, we can kind of zoom back out and look there that our blended savings value for just the storage increased relative to when we ran storage only. So again, this is the solar plus storage project. The savings from storage coming in at 107 per kilowatt hour, well, that's better on a $1 per kilowatt hour basis than storage could do on its own. It's the takeaway there. Okay, I know I'm moving really fast. I've got a couple other roundup slides that I want to go through before we pass it back for Q&A. So I think I'm going to transition out of the demo and kind of run through a couple of my last slides, and then we'll go to Q&A. So let's talk very briefly about a question that's coming up a lot. You know, if you're a solar developer and you've got a lot of customers, you're obviously thinking about, well, where should I focus my resources? Where are the best savings opportunities? What are the best use cases? Obviously, on the utility rate tariff side, it's going to be a big driver. So if you're doing CNI and if you're doing peak shaving, peak demand charge management, you obviously want to compete against high demand charges. This is a back of the napkin number that I know some CNI storage developers use. I think if you have over $15 per kW demand charges, it's certainly worth looking into that project. If you're doing time of use arbitrage, as we just looked at a minute ago, you want to compete with wide time of use differentials. You know, the wider the better. The same applies to self-consumption. Hawaii is the great example there. You know, if the retail rate of energy is 25 cents and the export rate of energy is 0 cents, well, that's a wide opportunity to kind of really extract value when you run the simulation. The load profile of the customer, it really plays into it. We just looked at an example. I'm kind of not going to be able to talk on this much in depth just because we're running out of time, but that office building type load profile, that lends itself really nicely to coupling solar plus storage. It just really allows storage to be economically viable on a $1 per kilowatt hour basis. Much more so than if storage was on its own, and also more so than other types of load profiles. There are other load profiles out there that do not lend themselves well to storage. For instance, you could have a customer that has high demand charges, has $25 per kW demand charges, and you're excited because you think you have a really viable storage project. But that's not the case if, like, let's say that customer is a cold storage facility and their load profile is just one straight line because they just have, the chillers and the freezers on all day, every day. You can't shave much demand for that type of load profile. Obviously, another one, incentives. I'm not going to kind of talk more on that. That's pretty intuitive. The next one I do want to talk on is the motivation of the customer. So, everything I've talked about for the last 30 minutes has been about quantifying the savings opportunity from energy storage as a result of the rate tariff that the customer's on and the load profile that they have. But the reality is, in a lot of the conversations we're having right now, there are other motivations that are where customers are going out and buying storage systems. And if you're a sales guy, if you're a developer, really a lot of these other things are things you're going to be highlighting. Obviously, backup power is a huge one. Not as easy for us to quantify an actual value on what the worth of that is, but in a lot of cases, customers are doing storage projects just for that backup component. Energy independence. Obviously, a lot of these early movers, these are folks that have solar systems, that have EVs. They want to produce their own energy. They want to charge their automobiles with it, and they just want to be as little reliant on the utility as possible. Future-proofing solar savings. I'm actually not going to have an opportunity to kind of talk too in-depth on this. Maybe I'll just spend 30 seconds. This effect is very much happening in California right now. In California, all three of the big IOUs are proposing pretty significant changes to the time of use rates. And what's effectively happening with the on-peak windows shifting much later into the evening is that the value of solar is getting eroded. So in a lot of cases, maybe you sold a solar system a year ago. Well, the savings, the actual avoided cost from solar is actually getting degraded. And folks are looking at selling a storage system to preserve those savings, to hedge against those future rate changes. And it's a real motivation. Okay, I have one last thing to do, Kelsey, before I pass it back. This is maybe the most important thing I'm going to tell you guys all day. I'm actually going to go back very quickly to my screen share. Bear with me. I promise I'll keep this really short and sweet, but I just gotta make sure I hit on this. Okay, so we've talked a lot about, simulations and optimizations and kind of a lot of these technical terms as we're modeling storage projects. But I want to kind of remind you, Energy Toolbase is a sales tool. And at the end of the day, this application is valuable if you can ultimately use a software tool like this to sell a project to your customer, to sell a storage project to your customer. And to do so, you need to kind of bake this stuff down into more simple terms. And going back to a lot of those customer motivations, in a lot of cases, when you're presenting analysis to them, you're going to really be highlighting some of those other benefits, not just the savings component, kind of really showcasing, okay, well, this is how it can make you energy independent. This is how backup power works. And what I'm showing you here is a proposal template. And we're really excited about this at Energy Toolbase right now. We actually just hired a full-time graphic designer, which we're really excited to onboard this week. And we've got some awesome ideas for presenting storage analysis to your customer in really clear and really simple terms. And I think the way we envision it is, ultimately these are your proposals and your templates, and you can kind of organize these however you see fit. But, for the time being, as the storage industry is trying to get its legs and kind of transition to making projects make sense, I think you'll have custom templates where you're really showcasing, the value stream that you're doing for a particular customer. And you're coupling that with some of those other non-monetary value streams and really kind of telling a story and hopefully doing it in simple terms and kind of explaining some of the backstory that, that we know about. But I just want to mention this because it certainly is a big challenge out there in the market now. We could talk really technically about all the finer points of modeling storage projects and goal-seeking optimizations, but that's not good if it doesn't get you to a finished deal. So I want you guys to know, as my parting thought here, Energy Toolbase is thinking really in depth about ways to communicate this analysis to your customer, and we're going to have a lot of awesome templates in our library that you can kind of take and run with and really showcase some of those other benefits. So I think, Kelsey, I'm going to pass it back. I think probably everybody's tired of hearing from me. I think I ran a little long, but I'm good.
Sure, yeah. So we only have time for a couple questions, but Adam can answer the remaining questions via email. So let us start with the first question. How long until the bugs will be fixed so we can target ToU arbitrage?
I'm glad you asked that question. And so I just gave you what I hope was a pretty polished demo. I just really showed off kind of all this awesome capability that Energy Toolbase can do. We will also humbly acknowledge we're still working through some issues. This is tough. We're trying to model storage projects all over the country for all types of customers, for all types of load profiles, and we are still washing out a few bugs. And the answer to that question is our engineering team is logging everything, and we're sprinting to make these corrections. I would tell you, having been live on this release for 2 months, we're incredibly proud of, I'd say we're 95% bug-free, but there are some issues we are aware of and we're patching. And please keep sending them to us, and I promise you we are on the ball with getting these patched and getting this all fixed.
Okay, the next question, is it possible to have the system recommend a PV battery kilowatt capacity and battery kilowatt hour capacity by uploading the customer's load profile?
We run the optimizations independently. So we have a really powerful optimization for solar as a function of the load profile and the rate schedule. We also separately have an optimization engine, which we looked at for storage, but those are independent, and they have to be independent because, for instance, if you have a 20 kW DC rated solar system, when we go and run the storage optimization, we're running 10 independent simulations, assuming you're pairing it with that 10 kW DC rated solar system. So the answer to your question is we have optimizations for both solar and storage, but they run independently.
Okay, next question. How does the pricing structure work? Do you grant a license to your customer to use the package?
Oh, I'm so glad you asked that. Our pricing structure is listed right on our webpage, and actually this is a good segue for me to say one last parting thought, which is if you register for a free trial of Energy Toolbase and you mention that you heard about us through this webinar, or you mentioned you were on this webinar, we'll hook you up with an extended free trial. When you sign up, just go ahead and mention that, and we'll give you an extended free trial when we reach out to you. The pricing of our product is listed very transparently on our website. Currently, it's $150 per user per month if paid monthly, and it's absolutely unlimited use. But really, the key thing I want to tell you is you can get, we want you to trial. We don't want your money out of the gate. We want you to test drive this application, and we'll assign you an account manager, and hopefully we can show you that this delivers value. So.
Okay, the next question is, can I upload my own data, which includes storage, and be able to calculate bill savings?
Absolutely. We left that feature in there. We fully realize that there are other applications, there are other engines for generating that simulation file that a lot of times are based on proprietary logic. And if you want to run that in Excel on your side or use another application, there's a lot of other folks out there in this space that are doing the forward-looking analysis. Absolutely, you can upload that into Toolbase, and then the real beauty of it all, and I didn't really talk about this much today, but it's the transparency in which we run this analysis. You know, we are just an absolute open book, showing you all of the inputs, all of the simulations, and then showing you the outputs as well. So the answer there is yes, and we'll do so transparently.
Okay, the next question, does the ToU Arbitrage analysis consider the avoided net energy metered value with solar and storage?
Yes, it absolutely does. We call them net metering version 2.0 assumptions. You define those specific to a project. So in California, we didn't talk about this, under the non-bypassable charge framework. Let's just assume non-bypassable charges are 2.5 cents. Yes, the answer is absolutely. When energy exports to grid, it's getting a 2.5 cent discount if that's the way you've configured those NEM 2.0 assumptions. So yes, it absolutely does bake that in, and it's determined by how you've defined those assumptions in the model.
This next person asks, I am familiar with the tool but struggle with locating payback period. It seems to be reported in documents rather than front and center. Yeah, we actually have that on our dashboard, and certainly when you're looking at financial metrics, again, the title of this presentation was about the economics. That's more than just savings. That's payback period. That's internal rate of return. That's net present value, however you want to express that. We actually have some really awesome dashboards. I think we just need to jump on a quick private call with you, with your account manager, and we'll show you exactly where to reference that, because certainly when you're talking about the payback or the rate of return, well, that's a function of we call it transaction. Is it a cash purchase? Is it a loan? Is it a lease? Is it a PPA? We've actually got a pretty fully built engine for defining the parameters of different transactions and really, again, quantifying payback or some financial metric against that. So the answer is we absolutely do that, and I bet you in a 5-minute private call,
we can really illuminate that for you.
All right, the next question is, can Energy Toolbase sort hourly interval data into user-specified time of use periods? And in parentheses, it says, an example, different than existing utility time of use periods.
Absolutely. Not only can you custom create rate schedules in Energy Toolbase through a really kind of easy, intuitive kind of front-end tool there, we actually have gone out and preloaded a lot of the, for instance, California proposed rate changes, where you have those time of use windows shifting much later into the evening. And this is something a lot of our users are running because, you know, obviously they're thinking ahead on behalf of their customer, knowing that the value of their solar is going to get eroded. And they're trying to evaluate, okay, well, 18 months from now, when that rate change is in effect, if I pair in storage, how much of those savings can I preserve? So the answer is absolutely yes. And again, get with your account manager and we'll set that up for you.
All right, next question. Will the ETB optimizer provide guidance on ESS without inputting any kilowatt or kilowatt hour battery info?
Yes, you can run it. In fact, that's the standard workflow that I'm seeing right now. Folks, you don't have to define anything. The only thing you need to define to run a storage an optimization is the control setting parameters. For instance, you need to tell me if you're peak shaving or if you're stacking, if you're peak shaving and doing ToU arbitrage, or if you have constraints like it must charge from solar. You need to define that, but you don't have to tell us anything about sizing. In fact, I'd almost encourage you not to. Just run the optimization first, and you're going to kind of get, you know, guidance on how to best size it. But you do have to define the you know, the control settings info, because that really is what dictates the savings opportunity.
Okay, and then for our last question, does the software calculate the cost of the energy that is produced by the PV and battery system?
Yeah, we try to express that every logical way. So obviously there's an average blended cost of energy, and then we also want to break out both the value of solar component and the value of storage component. We're frankly still kind of toying around with the best way to express these, but yeah, the data does exist, and we just kind of have to show you where to reference on your dashboard of your deal to pull that value.
All right, that is all the questions we have time for today. If you have additional questions or we didn't get to yours, feel free to contact our presenters on your own. Again, this webinar will be shared with all registrants, so you can view it again at your convenience. I'd like to thank Adam again for being here and Energy Toolbase for sponsoring today's webinar. And thank you to everyone in our audience for participating. I hope you enjoyed our presentation, and we invite you to join us for more Solar Power World webinars. Thanks, everyone.
Thanks, Chelsea. See ya.